All right, we are live again. Welcome everyone to day 2. Whew, I think I'm getting some
Hello.
feedback. I'm gonna have to get my headphones here.
Hello.
On that. How y'all doing?
Great.
Good. Monday blues.
Yeah, as somebody said, Monday. We're here at Monday again. It's back.
Yes.
I love it.
We
I love
just
it.
started again.
I'm just putting on these wonderful headphones here. We already have folks joining in. That's fantastic. Oh my gosh. I'm sorry I decided to do this one a little bit earlier, but I've got a packed day, so I kind of need to bounce around a little bit here. Come on. Here we go. It's so much better. I was getting the audio coming in through like my TV, and then like it was just sounding a little bit off. But anyways, hello everyone. Welcome to the stream today. Welcome. We're gonna dig into some interesting stuff because last week we were a little bit higher level. We talked a little bit about some of those higher level concepts in networking, and I think it's good that we dig into like some of the hands-on stuff. So what I'm gonna do is I'm gonna show y'all what I've been up to, and we've got roughly about an hour. Oh no, I think one of my instances is having trouble.
Mhm.
Oh no, they're all good. Sorry, false alarm. False alarm. All right, I'm gonna share my screen. So what do y'all do this weekend? What were y'all up to?
Oh, took my toddler swimming. That was abject chaos. Went climbing. That was good. Ate a lot of food as normal.
Awesome.
Go ahead.
Oh, yeah. I was spending time to learn some video editing and was watching movies with family. So yeah, that was pretty much about me.
Yeah,
What about you?
I did. I did my usual dancing and then some exercise, aerial exercise. So, yeah.
That's nice. That's nice. Like you don't join any classes or something?
Yeah. I'm doing some classes for like both, like one for dancing and other is aerial. So
Sounds fun.
So yeah, I like Leon's new setup too. He moved to a brand new place. Did y'all hear about that?
no. What?
I'm just kidding. That's a very, very familiar background. All right, so
yeah.
let's dig into it. What do we have here? So I've got the fantastic Civo Kubernetes dashboard, or Civo dashboard, I should say, because I'm looking at 3 virtual machines. So one of the main goals of today is let's bootstrap these 3 machines into a Kubernetes cluster and even get Cilium up and online if we can. It's going to take a bit because each one of these machines requires a runtime, a container runtime. It requires some of the Kubernetes binaries to run, and it just needs to be bootstrapped. And I haven't done this in a long time. And what's interesting is I probably wrote a blog post about this a long time ago. And let's go take a look and see if I have something. Hash node. Did any of you ever write blog posts around how to get Kubernetes up and running by chance?
Oh, many moons ago I did. Yep.
My favorite is the K3s one. So and I use the K3s up command by Alex Ellis. So the breeze with that. But yeah.
Yeah. K3's up is a fantastic system. So let me drop this into here, and I'll quickly share this tab instead. Okay, so I don't know how relevant this is today because there's so much that probably has changed since I wrote this article. But basically, it's exactly what we're going to do. We're going to deploy Ubuntu. We got to have 3 nodes, and we do have 3 nodes already ready to go. I got to install Docker, or is there an alternative that we can install today?
Container D on its own generally.
Yeah, so we can do container D, and then we need to bootstrap this with kubeadm. I think some of this is like probably outdated. I don't know. Maybe I should come back and update this article, but it gives us a good idea of where we need to go. So I think what would be ideal is if we went to the Kubernetes docs, kubernetes.io. Okay, so while we're looking through this documentation site, the one thing to be aware of is that we've got these 3 nodes here, which are going to act as both our control plane and our data plane. And what that means is all of our Kubernetes control plane components will live across these 3 nodes, and we'll also label them accordingly so that they can run standard workloads. Why I might do this is just because, I don't know, I want a high availability cluster. Maybe we might get to use kubevip somewhere, and we get to see some of the benefits of setting up a high availability cluster when we take out a node and see what happens in the realms of Kubernetes. But behind the scenes, right, like what we also need to maintain is each one of these has, oh, you can't see that. Each one of these nodes has its own like private IP. Now, each one of these private IPs, they're on the same network, which means these 3 nodes should have connectivity to each other. Meaning if I happen to go onto K8s node 1, which I will do in a second, if I can SSH into it, and I'm going to stop sharing because I don't want you to see my SSH credentials or anything like that. Not that you would be able to, because quite honestly, they even hide it, which is beautiful. That's what I truly appreciate about Civo. All right, so let me just get this new window here. SSH root at, what's this site? Oh, wow. I just realized PowerShell does not have SSH. What? How come I don't have SSH? This is so strange. I was like SSHing from my system so many times before. Let's see if this SSH is not a recognized. What? What?
Windows should have it, right?
Yeah. Windows SSH client. This is so for what? I have to add it as a feature? Oh my gosh. Okay, I did not sign up for this today. Anyways,
This is the future that we were promised. No SSH client.
all right, let's wow, it wants me to create a profile. Hey Charles, how's it going? All right. You know, while I'm getting this going, Dan, why don't you share some of the inner workings behind why nodes need to communicate with each other? What kind of information is being exchanged across those nodes?
Sure. So as Marina mentioned, we're going to share responsibilities here, but in production clusters, typically you have the architecture of the control plane, and you have then the architecture of the workers that sit underneath the control plane. So typically you'll have a odd number of control plane nodes, and they will host all of the control plane components. And then you'll have as many worker nodes as is required in order to sit and have the workload running on them. The control plane nodes, it's quite a cool way that it kind of all hangs together. So as I mentioned, you need an odd number of control plane nodes, and that's because of the underlying mechanisms that are required. And namely, that is there's an algorithm called Raft, which is what does the leader election, that basically is what kind of holds everything together. So we can start with a single node. We bring up Kubernetes on that. There'll be a leader election. There is always a leader election. And because there's only one control plane node, one leader, it's a pretty simplistic leader election, and that single leader will win. But, that is a single point of failure. If we lose that single control plane node, we can no longer do anything with our workers. So typically we'll need a number of these control plane nodes. So most people will opt for 3. You can have more, 5, 7. The problems with having more and more control plane nodes are the leader elections start to get more and more involved. it's more resource to manage and control. And etcd is a bit of a crazy tool. Etcd is kind of what is holding all of the persistent data of everything that's happening in that Kubernetes cluster. etcd also utilizes Raft in order to do those leader elections and things like that. So typically, as I mentioned, most people opt for 3 control plane nodes. etcd is started on all those control plane nodes, and it will communicate between one another and ensure that all of the nodes that participate in that control plane are always synced up with the same data. So if we lose one of those control plane nodes, one of the others will take over via that leader election. And they all have, they continue pretty much where they left off with that set of data. All of the other components that are part of the Kubernetes control plane will then sit on top of all of that. So the API server, which is what you interact with, that sits on top of etcd, which does all of that data duplication back and forth across the cluster. So in terms of east-west, as in, in terms of the communication that's happening between the control plane nodes, it's largely etcd that is speaking to nodes left and right. If you speak to the API server itself, so you do a kubectl get, you speak to that API server, and that API server then speaks to the etcd, which is speaking left and right. So it's etcd that is the requirement for being able to speak to all of the same nodes in the control plane. That pretty much covers it. Does that make sense?
That makes complete sense. And what's really interesting, so I am so spoiled when it comes to SSH that I've always used a Mac. And I just remember that I had to download an SSH client like Putty for Windows. So here we are, Putty. If you don't know what it is, go ahead and download the magic of Putty. If I can find the window, here we go. All right. So here's my Putty window here. Let's see if I can make it a little bit bigger for all of us to see. Okay. So if we did an ifconfig or IP link maybe, or IPADR, there we go, IP address. I don't know, there it is. Okay, so we've got 192.168.1.4. So that is one of the nodes in our environment. Now, if I go back and look at the other nodes in my environment, I have 1.4, 1.7, and 1.8. So if I did a ping 192.168.1.7, it's going through, which tells me that they're on the same network. And if I do a 1.8, okay, so now I know that both my nodes are on the same network. I'm actually curious, if I did a simple NS lookup, would it resolve the host name? If I did a NS lookup, or actually I should say dig K8s node -2. Ooh, it did not resolve it. Did it resolve it? I don't think it did.
There's no IP address next to the A record, so there's no...
Yeah. Let me try this. Dig 192.168.1.7. It doesn't know about it either. Okay. This might be fun, which means we need to have DNS somewhere, right?
You could do DNS. You could add everything in the etc host file for each of the nodes.
Marino, could you enlarge the font like people are saying they can?
Okay. Yeah, okay. That's the max I can do, unfortunately, because of the way Putty works. Okay, there we go. Okay, all right. So that's the max I can do, but I think I like Dan's idea about the etc host. So what we can do is we can do a sudo vi/etc/hosts. And what this takes me into is the local DNS file of my host, meaning anything I do here. So if I type in 192, I type in I, obviously, 192.168, let me verify what that IP was. 1.7. would translate to K8s no-2, and then 192.68 1.8 with K8s node-3. Okay. WQ. Now if I do a cat/etc/hosts. Okay, so if I did a ping K8s node-2, look at that. All right, so DNS resolution is kind of working because we've hacked away at it. Now, the reality is, like, would I want to do this at scale in production? Absolutely not. Like, logging into every single Linux host to mess around with Etsy hosts is just like impractical. This is why we have DNS servers. We can have a central reference point that we can modify, update, and then everyone will point to it. What were you going to say, Dan?
I was about to say, in some production places, I have seen Ansible doing this on massive scale. So instead of simply setting up DNS, every now and then, Ansible will kick off and it will update IP addresses on all of the boxes and stuff like that.
Yeah. All right. Okay. So we know that we have connectivity. I can mess around with the DNS stuff on the back end. So while I'm doing that, Dan, Akansha, Leon, why don't you all dig into the Kubernetes docs? Let's figure out what we need on our Linux system, and I can pre-populate that behind the scenes, and then we can get that going. Who wants to share their screens?
Anyone? I can.
Yeah, go for it, Dan.
All right.
Yeah, go for
Bear
it.
with me.
I have too many tabs open.
I mean, we're all at that point where we have too many tabs open, I think, at this point. Let me just get the docs up. Yeah, so as Marino mentioned, Kubernetes is made from a lot of pieces. It's not just one thing that you kind of set up, not like Docker Swarm and things like that, where you grab Docker and just type Docker Swarm and you get a magic orchestrator. With Kubernetes, it's built upon a number of different technologies. There's all of the Kubernetes components itself. So you have everything that comes from the Kubernetes project, which is things like the kubelet, which runs on every node, the API server that you interact with, schedulers and things like that. Some of the other bits that are actually required are things like the CNI, the CRI, and the CSI. And those are those are the bits that are actually doing the work. So you throw some YAML at Kubernetes and ask it to stand stuff up. It will need to interact with the CRI in order to actually stand up some containers. So the CRI stands for the container runtime interface. It's a standardized way of Kubernetes being able to speak to a runtime. Runtimes such as container D. The CNI, container networking interface. And that is the standardized way of Kubernetes being able to stand up networking for the for what it is that you're actually running. Cilium being the CNI that I tend to talk about all the time. And then the third leg is the CSI, which has nothing to do with the crime show. The CSI stands for the Kubernetes storage interface. So when you have in your manifest that you would like your pods to stand up and have X amount of gigabyte of persistent storage mounted here, there, and everywhere, the CSI is what's going to be speaking to a storage backend, whether that's something like S3 or on-prem. It may speak to some storage platform and attach some storage to your nodes as they come up. So those basically are kind of the three legs that Kubernetes sits on top of, and it is those things that are actually used in order to provision actual infrastructure. I'm not sharing anything at the moment. What is a CSI? Container storage interface. So let me... Okay, cool. So there is actually some diagrams. I will share my screen. Bear with me a second. And here we go. I'll need to make this a little bit bigger, I think. Can somebody bring my screen in? Because I don't have the power. There we go. So these are some of the components that I talked about here. I'll need to make it bigger. So we can see we have the control plane, and we can kind of see in here we have etcd as part of the control plane. We have the API server. We have the scheduler, which takes care of organizing of where things should actually go. 1, 3, odd number of nodes needs to make up that control plane, and that's because of etcd. And then the API server, on each of the nodes, you have to also install some components. And those components dial back to the API server and continuously ask about what they should and shouldn't be doing. The two main components that run on worker nodes, one is the kubelet, and the other is kubeproxy. Kubeproxy is in charge of making the nodes have the correct networking information. So kubeproxy will set up the various rules that are required in order to move traffic around. And we'll go into more detail about that a little bit later on. The kubelet is arguably one of the most important pieces of Kubernetes. The kubelet is the thing that speaks to CRIs, CNIs, and CSIs. So you apply a manifest to the API server. That manifest, blah, 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 says my application should look like this. The scheduler will take care of choosing which nodes should have those workloads on there. And then it's the kubelet's job in order to set the state on the node to what is actually in the API server. So if it's scheduled for 2 pods to run on the first node, the kubelet then will take that information, speak to the CRI, bring up the containers, bring up the networking, attach the storage that is actually required. And that's effectively what's doing the job. So that's, these are the components that hang on, that basically set up, bring up and set up the infrastructure. How are you getting on, Marino? Need a little bit more time?
Yep. You keep going. I'm just trying to get all these right pieces here.
Sure. There's one other component which most people don't really need to worry about on-prem, but in the cloud environments it's the way of how it all kind of hangs together. And that component is the Cloud Controller Manager. So on the right-hand side, it says optional here because you don't always need it. But the Cloud Controller Manager is kind of an interesting thing because its job is to speak to the API server, watch when things are being provisioned. And a Cloud Controller Manager's job is to be able to speak to the cloud environment. So if you are setting up nodes and you're in a EC2 AWS environment, you would install the Amazon Cloud Controller Manager, and that will have the capability of being able to understand things like EC2 instances and what's actually happening in the cloud, and provision things as and when needed. One of the more common use cases are you create some pods, you want to expose those to the outside world, so you expose them with a service of type load balancer. Now, dependent on which cloud environment you are, it's a different mechanism for speaking to the infrastructure to provision that load balancer. So, yep. It's the same in Azure and it's the same in Google Cloud, and it's probably the same in Civo. They probably have a CCM as well. But yeah, when you expose a load balancer, it's the Cloud Controller Manager's job to dial back to that infrastructure, ask for an ELB or an ALB or whatever particular type of load balancer is exposed by that infrastructure. It will get those resources and plumb that into the Kubernetes cluster so that it now runs natively within that infrastructure and uses its various functionality. So a Cloud Controller Manager is an add-on, but it allows your cluster to be able to work effectively in the infrastructure in terms of where it's running. So those are kind of all of the components. As I mentioned, etcd for all the data store, API server for interacting with Kubernetes as a whole, Kubelet for actually doing the provisioning of containers and networking and storage. Kubeproxy for setting up all of the kind of networking. And the Cloud Controller Manager if you need to be able to speak to the infrastructure on where things are actually running. So that's pretty much it. Have you got any questions or anything? No. Okay, cool.
Cool. All right. Hello, Carlos. Welcome. All right. So I am currently setting up containerd. But here's the thing. Because I've been so spoiled and just auto deployed Kubernetes clusters, I actually haven't had to do it the containerd way. So let me share my screen and show you where I am getting stuck or where I need to go from here. So here's where I am. I've got this applied on my Linux node, and I've verified that all of this seems to be good. But it's very misguided from this point on. Like, it just says, oh, C group drivers, system D, C group, and it doesn't say like what you're supposed to be doing. So, any tips, Dan?
I think largely, so let me scroll down a little bit more.
Maybe I could go here.
Yeah, I mean, I think for just getting things up and running today, we probably don't really need to make any changes really, other than the ones that were higher up.
Yeah. Okay. And then I could probably, why did it point me to Docker?
Oh, because I think it's still in the repos from the Docker project. So as a quick aside, containerd was spun out of Docker many, many moons ago. Originally, everything was all packaged within Docker, and then they started to kind of pull components out a little bit more and standardize things.
Okay, so let's try this. Let's try installing from source and see what happens here. Oh, dang it. That did not work. I have to curl it first. More stable release. Okay, here we go. So I'm just going to curl that file link.
Yeah. So if you add you've added the repo, then if you do an apt install containerd.
Oh, I could just install the repo or clone the
Yeah.
repo. Okay, I guess I could do that too. Let's go to containerd. Let's copy this and then git clone. I really hate when it adds the unnecessary characters. It's always fun. All right. Okay.
Oh, hang on. Sorry.
Where can I read the bank?
So you've added in the hang on, the screen's going to turn off. You've added in the repo for containerd, not the GitHub repo, the Docker Ubuntu repo.
Oh, that's what you meant.
Yeah,
okay. 1 second.
I think it's in the chat here. The StreamYard chat.
Oh, nice. I love this. Okay. See, y'all are just speeding me up by saving my life here. Ah, dang it.
Is that not pasted particularly well, I imagine?
I don't know why I got stuck.
The hyphen, just do it again, the hyphen. The Mac thing, I guess.
I'll just delete the sudo app stuff. So go all the way to the end of dev null, and then we can do all that afterwards.
What?
That's weird.
Let's try this. Let's try this carefully, line by line.
Is there a different
I've
way?
always gotten into this. It's like not what missing arguments. There must be something the way this is enumerated on this chat.
Yeah,
That's why it's
maybe
not working.
let's break it down a little bit.
Where's the link to this, or where's the link that you got this from?
Just here.
Okay.
It's an old blog post, basically. But effectively, right. There we go.
That worked.
Right. So just to explain to people what we've actually done here is we have pulled the GPG certificate, basically, for being able to speak to that particular repo. Now that we have that, the next line
Should be the echo.
which is basically going to add in that repo so that we can actually pull from it. So somebody asked why we, unless, yeah.
Okay,
There we go.
That worked.
So now if we do an apt-get update, we can now see, if you look at the list of things.
Docker, yeah.
Oh, what we've got 404. I get a feeling this isn't going to work.
Marian, do you want to try Arcade?
No, let's not try and do things the easy way, because we really want to expose how difficult things are, right? Like it'd be easy for me to run a script and run
This is jam.
Yeah, but it would be easy to run like. Oh, wow.
Yep. I think you need to do update first.
Yeah. apt.
No. Oh, it doesn't have the release file, the sources list D that we created, right? Can you check if it has this file, the one that we tried to pipe into? Windows.
It does.
Where? Okay. Is not found. Download Docker Linux Ubuntu release. Ubuntu. Oh, okay. It cut, I guess.
I'm gonna do this with Docker Engine, because I feel like we're getting a little too like all over the place, and let's try this with Docker Engine. So there was a question from Carlos. Why are we doing it with Docker? Well, it's just the fact that we're bootstrapping Kubernetes with kubeadm, and okay, installation.
I think it's fairly easy if you just take the release file and do it. They have an entire good doc for that.
I'm just literally following the documentation right now for a Docker. So we'll get it up and
Okay,
running.
that's good.
Yep. So for folks curious what I'm following, if you all want to follow along too on your end, this is what I'm using. So what did I just run? Get update. Okay. We're going to now install Docker. Yes.
So you can see there that it's installing Containerd as well, because Containerd is part of Docker.
All right, let's see if we can get a container running. Okay, that worked.
Does
So,
the containerd command separate in this? Can you check that?
what? Sorry, what's that?
No, I was just saying, is the runc thing separate, or is it like inside the Docker binary or something like that?
No, runc
Because
will
then
be
you could just,
installed separately as well. So if you scroll up a little bit, we should be able to see that it was installed.
yeah, then you could just use that instead of like if you wanted to use containerd, like it's installed it for us. So.
Sure thing. Why is Docker needed? People are going to be confused. Carlos, I understand your confusion around the usage of Docker. We're using a runtime here for this live stream. We could use anything. And quite honestly, just for the sake of us getting up and online, we chose Docker because we were jumping around trying to get the right commands up and running for Containerd. So I'm going for simplicity and what I know. Having said that, that doesn't mean that we can't use Containerd to run it. And this is not the same as using Docker Desktop, where you actually have that full UI in front of you where you can spin up containers and visually see this. We're just using the Docker engine behind the scenes that is providing us the Containerd runtime. So this will enable us to get beyond the requirements which Kubernetes is asking us for in order to bootstrap this with kubeadm. So having said that, let us install Kubernetes with kubeadm. So I'm going to pull up the docs. And we're going to take a look at it. And it's saying we've got the container runtime ready to go. And then we got to use kubeadm kubelet and kubectl. So what we want to do now is we're going to update the repository here, and let's just see what happens. Okay, that's looking good to me. We'll download the public signing key. And then, no, we don't need to overwrite that. All right, now we can install the, actually, hold on. Let's just do this just in case.
Yeah, that's going to add the repo to a list of repositories that we can pull from.
Exactly. All right, so now I'm going to run the magical sudo apt-get update and download all the necessary Kubernetes components. So what you're not seeing is what I'm doing on my CLI, but I hope that the StreamYard folks are listening into the conversation and now know what's going on and realize that we should have multiple windows or shareable windows. All right. Anyways, then we're going to use kubeadm to bootstrap the cluster. Initializing your yes. Now we have to use kubeadm init. Whew, this is fun. All right. API server advertise, control plane, endpoint. All right, Dan,
Yes.
Question for you. This is where it gets interesting, because this is probably where we want to consider like kubevip at this point, right?
Yeah, I mean, we'll do a kubeadm init first, because we can do a kubeadm reset at any time. But we can do a kubeadm init. We'll just do a single node stand up, just to basically step through everything that's actually happening.
Yeah, that's fine.
So one of the things, it may seem a bit confusing. We could have just installed containerd on its own. We could install Docker because it pulls containerd along with it as well. But because we've got Docker installed, we can actually interact with these containers that containerd is actually going to stand up for us. You don't need Docker installed on your worker or your control plane nodes, but it's just going to make life a bit easy for us today. Are you going to pop back to your terminal?
Oh yeah, that's right. I thought y'all can see what was going on my side. Okay, how does that look?
Okay, so this is going to be where the runtime's in the wrong place. So the problem that's happening here is that it's unable to find the containerd endpoint. So when is containerd actually running? If you do
a systemctl status containerd.
Yeah.
Yep,
so containerd is actually up and running.
So it's just the endpoint that we need to change.
Yep. And how do we do that? Bear with me a second.
I don't see any socket inside this service. The socket not created or somewhere else. Systemd should show the socket path too.
Okay. So when you do a kubeadm, you can pass the is that the one that's
kubeadm, and we could pass the what?
Where the endpoint actually is. You may need to pop into var run whatever to try and find out what it's actually named as. This is unfortunately a side effect of us using Docker to install containerd, because it's set the endpoint to something slightly different. Containerd by default.
Sorry, what do you want me to look at?
So go to /run.
/run.
CD /run and find /run, yeah. Containerd, and then have a look in there. Right, so there's the socket that we need to connect to. So that looks right to me. If you do kubeadm init, what's the error again? Okay. So in our private chat, you'll find out the flag that you need to pass to it.
Oh, I see that. Okay.
And that will basically mean that kubeadm speaks to the correct socket. Yeah.
Container runtime endpoint. Is that the right flag? Unknown flag, container runtime endpoint.
Well, this is according to the Kubernetes documentation. Bear with me a second. Oh, it's been changed to --CRI-socket.
That's so. That's a docs issue. If anyone's interested in
this could be an
submitting
old documentation I'm reading. I mean, it's on the Kubernetes.io website, but it's when we migrated from Docker to Containerd
what was it again? CRI
-socket.
socket. Okay. Socket. Oh, okay. What's this now? Container runtime is not running.
That's a weird one as well. I think an alternative then would be, can you try the command containerd and just see whether that exists? Okay, Control C. Right. What we're going to do quickly here is we're going to reset containerd to its defaults. So in the private chat.
Okay.
And then restart containerd. Right. If you just do a kubeadm init now and see whether it's put the socket in the right place.
Do I need it with that CRI?
No, not the CRI socket, just on its own.
Oh, that looks so much better now.
Yes. So, do you want me to quickly explain what's happening?
Yeah, let's go for it. I want to learn.
Sure. So, kubeadm init is quite cool. It's a very clever tool. The alternatives were basically doing a lot of things by yourself, making your own certificates. Doing there is Kubernetes the hardware, which is by Kelsey Hightower, which is just steps through doing all of this yourself. kubeadm automates everything. So what kubeadm has done right now is it's created all the certificates that we need in order to have the backend certificates for the API server and the client certificates that we will use in order to speak back and forth. Additionally, what it's done is it has created a folder called /etcd/kubernetes/manifests. And in that folder, you will find all of the manifests for standing up all of the Kubernetes components. So these pods that we see that are coming up here, these pods are started by the kubelet. So can you pop into the /etcd Kubernetes manifests folder for me? Yep. So we can see here we have these manifests. These are all of the control plane components. And the kubelet is now going to stand those components up for us. Amusingly, all of the API components don't run inside Kubernetes. So we can see them actually running. They run separately, and they're called static pods. So kubelet is in charge of standing them up. Kubernetes is aware of them, but if we try and edit them in the API server, so if we did a kubectl edit pod API server, it wouldn't make any difference because the static pod is what defines them.
Yeah, so I'm trying to remember where the static pod configuration is because I remember this from the CKS.
It's in this folder.
Is it under kube API server? No, it's on our kube controller. I can't remember where it is.
So those are all static manifests that you're looking at.
Oh yeah. Okay, yes, this is good.
So that's all of the config for the API server, all of the flags that are passed to it, and things like that.
Okay, so I do have a node, and I do have a cluster, except it's not ready. Why does it say it's taking a little too long now? That's interesting. It was working just fine a second ago. I didn't change anything here.
There you
Oh,
go.
it's just slow. There we go. Okay. All right. So with 10 minutes left, maybe we can get Cilium up and running. What do you think?
Yeah, I mean that should be relatively straightforward.
All right. Let's download the Cilium CLI. And if you head over to the Cilium docs, you can get it over here. Why can't they just have simple instructions to get it installed?
So there should be effectively all you need to do is get the Cilium binary.
Yeah, I have to do a wget copy link address or plus. Oh shoot. Okay. What?
No, that's
no, it's there. Wait, what?
That doesn't seem right.
I think it didn't name it properly. What the hell? Hold on a second. Okay. No, this is why, because I'm just being a very silly person at the moment.
so the URL's wrong there.
Yeah. There we go. Okay.
Hang on, that's for Mac OS.
Oh, what? No.
You've got Darwin binary there. So yeah, one thing to be aware of when pulling a lot of tooling, especially from places like GitHub, is we build for a lot of different architectures and operating systems. This is Darwin is the underlying name for Mac OS.
Yeah. I'm not paying attention because it's so early in the morning. I'll tell you what, I didn't sleep until 1 o'clock last night because I drank coffee later on in the afternoon. Biggest mistake you could ever
How
make.
much coffee?
I'm averaging 2 cups a day now at this point. XBF, Cilium, Linux.
All right. We now have the Cilium binary.
Cilium.
Oh, no, it's just a binary. You've got the binary in there.
Oh, yeah. Cilium. Don't I have to do a chmod or something like that? Or chmod?
No, it's green, so I think it should be okay. You just need to reference it in the local directory, that's all.
/ That's
the one. I don't think your cluster's healthy. Can you do a get pods -a? I think the API server's broken again.
It was just online.
Yep.
I'll just reboot and see what happens.
In the meantime, I've got a terminal up over here, and I can kind of take over for a few minutes if you like.
Yeah, that's fine. I'm gonna flip it to you, so I'm gonna stop sharing.
No worries. Bear with me a second, and I'll get this up.
We are so close. Like literally, all I need is just Cilium up and running, and we are up and online.
Right. Can somebody bring the screen in?
There you go.
So So let's quickly start with the kubeadm init. So as I mentioned, this is setting up the Kubernetes. It's pulling all of the images if we don't have them. I think I should have most of them, but we shall see. Once it's got all of those images downloaded, it will create the etcd manifests folder. It will populate the manifests for the API server. It will populate the manifest for etcd. Kubelet will be configured, and it will start all of those bits up and running. So I'm guessing it must be pulling down some of the... I don't know what. I've run out of space. Today is not going well.
It's just one of those days.
Yes, I don't know if there's anything I can do really to clear any space on this node either. I don't have Docker installed. So nope.
Well, we're getting there.
Well, kind of. Hang on then. Let me quickly try something and see whether we can get something stood up.
Yeah, no worries. I'm hoping that my node is up and operational now. Ah, that worked. That helps. Okay. So let's see. kubectl get nodes. What? Container D status. Yeah, we're just hacking away, trying to make something work. Oh, so container D is up and running. What's not running? Ah, that will help. Is kubelet running? Oh, that's a good one. Wow. The command I'd run is journal ctl-u kubelet. Why I know that command is from something when I was, oh, it seems to be good. So I think in my case, I just have to reset my kubeconfig.
All right. So we now have a Kubernetes cluster up and running, and we now have Cilium installed as well.
And I think I will have Cilium installed as well. Oh, dang it. Well, ls /.
There we go. Whew, managed to just about get something up and running. So I suppose to kind of loop back a little bit about what we were seeing. When Marino was doing a kubectl get nodes, the status was always set to not ready. The reason for that is until you actually have a CNI installed, some of the pods that are largely kind of part of the control plane won't actually start. So one of the other, and we've not really mentioned this, one of the other underlying pods that's actually required for your cluster to actually work is a core DNS. So if we quickly do a kubectl get pods, we'll see now that these, oh, they should have come up. Okay, once the API once it's finished coming up, they should start to come up. But yeah, without a CNI server, your cluster won't be marked as ready. So until it has networking capability, it will be given a node taint, and that node taint, with it being set to not ready, means that pods won't be scheduled to run on that node until it is of a state ready. And once you have your CNI actually deployed, then it will be marked as ready, and it will be ready to take actual workloads. So we have all the control plane components up and running. We have the Cilium CNI up and running. It's pretty straightforward to get the Cilium CNI. You get the binary that you actually need, or and it's slightly more recommended, is to actually use Helm, which allows you to template a lot more things and set things up as expected. But doing a Cilium install will effectively kind of under the covers use Helm to do a basic set of settings and get Cilium deployed, actually running on your cluster.
And hey, I managed to get it up and online too, kind of ish. Oh, dang it. I think my thing broke again. Literally, it was like, it was working just fine. And then all of a sudden it just decided to crash on me. Like, you see what was going on? Like, I actually ran the Cilium install command. And it started doing its thing. And then, I don't know, there's something wrong with this node. That's okay.
Yeah, this either etcd keeps crashing or the API server keeps crashing, and with that, you're not in a good place.
Yeah. That's okay. Well, on your end, you've got it up and online, so that's all that matters to me. So we are there. We got it to where we need it to be, except we had to hack around it a little bit more. Okay. Now this is a lesson for y'all. Do you bootstrap Kubernetes clusters with kubeadm and hack around with this to try and get this to production? Absolutely not. There are tried and tested solutions out there. Yes, it's probably my kube config, Carlos, or something's wrong with it. There are tried and tested solutions out there that prevent you from having to go through the pains that we just experienced in the last hour. But what's brilliant about this is, like, when you think about the physical network, right? You have a lot more control over devices because you're actually procuring devices, the right cabling, you're procuring the space to store these network devices, whether they're switches or routers, and then you have your endpoints, which are servers. Now, where you have a lot more control is over these devices because they offer up usually a central control plane or a central API, which is normally not scaled or managed. But what's beautiful about that is, like, the analogy here is, as you would do this physically with, let's say, a console serial cable, we're doing the same kind of thing, except through SSH and a CLI to basically take a bunch of nodes, connect them together so that they form a compute fabric plane. And then on top of that, we build a network layer, which is what Cilium is offering us. And then we run and ride our pods on top of that. So I think for the next stream that we do next week, I will have a fully operational Kubernetes cluster that I did not bootstrap with kubeadm, because obviously we don't want to do that again. But we'll have a cluster up and running. We'll have Cilium up and running. And we'll even look at a few ways to install Cilium. So there's a Cilium CLI that we could use. We could even use Helm. And there are reasons why we might use one or the other. Like, for example, if I wanted to use Helm, I probably want to customize certain toggles and features in Cilium. Like, I want to enable BGP and then take advantage of the BGP functionality to connect with upstream networks. Not that we're going to do this next week, but we'll explore that in some additional sessions as we continue to go deeper and deeper. What this should have given you an idea of is, once you've got your compute plane ready to go, we've just installed the network layer on top, which is the Cilium CNI. Oh yeah, so show how the CNI plugin conjured and how Kubelet knows about and chaining. Okay, so yeah, let's talk about that as well next week. So how does the CNI communicate with the CRI to onboard workloads and follow the whole IP address management process, create a network namespace, and ensure that that container that's in Kubernetes now has access to the network? So we'll explore a little bit more of that next week. Dan, any final thoughts, questions, comments?
No, I think we talked a little bit. We did some kubeadm stuff and things like that. It was a little bit scrappy on our end. Normally, it's much more smooth process. And I would say, if you look at things like all the cluster API providers, from vSphere to Nutanix to IBM Cloud to all of them, they all use kubeadm under the covers in order to kind of do all of that stand-up process. If you're using things like K8s, then that doesn't need kubeadm, but Kind is all based on kubeadm as well. That'll stand up a bunch of Docker containers that have full Ubuntus in them, and it'll use kubeadm to bind those all together as well. So the problem is that it's quite a complex thing to actually set up the control plane in its first instance. All those certificates need to start. You need to set up all these manifests and things like that. But once kubeadm's done its work, it's a case then of all the other nodes just doing kubeadm join and binding it all together, and it will send all that information back and forth that is needed. But yeah, now we're in a position where our cluster's up and running. Our CNI is actually up and running. we can deploy things and things will magically just work at this point. So I think we should probably start to look into that magic next time.
I agree. I think, there's a lot of assumptions that, the infrastructure is always ready to go. But the reality is there are people behind it who have to set this up, maintain it, manage it so that developers can take advantage of the beautiful things Kubernetes has to offer, right? But there's a lot to get there. And while there have been plenty of recipes that have been put out there, what if someone wants to do bare metal Kubernetes, right? And that's something I'm actually exploring with Kat Morgan and Michael Cade. We're looking into, getting Talos up and running on bare metal, and then using that as the control plane data plane to support virtualization for like VMs, in addition to container workloads as well. So if I wanted to run a container, sure I can. If I wanted to run, a nested cluster inside of Talos, that's going to be very fun to try out. We'll see how this goes. All right. Yeah, I agree. Thank you so much for coming out, everyone. Thank you so much, Carlos, for all the additional thought process and motivation here. And you're right. It's not a cluster until that second worker joins. So everyone, take care. Have a wonderful week. We will see you all next week, probably around the same time, maybe a little bit later, because I think 7:30 was a little too early for me. But take care, everyone. Have a great week. See ya.
Bye.
Okay.